presentation, I will introduce Finestlawsampo, cross-border demonstrator for searching and browsing Finnish and Estonian legislation on the semantic web. I am Eero Hyvönen from Aalto University and University of Helsinki. The team behind the work consists of people from Aalto University, Ministry of Justice, and Finnish Digital Agency. I will first discuss some challenges of the state-of-the-art cross-border searching systems for legislation. After that, a solution approach based on linked data is presented, and the proof of concept system Finestlawsampo is introduced. There are basically two approaches for cross-border legislation search. In the distributed federated search strategy, a query based on shared vocabulary is sent to national services, and query results are collected and translated and returned back to the query system. This system is used, for example, in the NLEX system on EU legislation. In the global strategy, the idea is to aggregate global data, harmonize it, and put it into a global knowledge graph for national services. Then also translations can be created if needed. The query is then targeted to the global knowledge graph and returns translated results. This is the model that we use in our Finestlawsampo system. This figure illustrates a cross-border searching system for legislation, NLEX. One can query the system with different languages. The query is then translated into national languages like Estonian, Finnish, or Swedish, and sent to local databases. The answers from there are then translated back to the query language. The user interface looks like this. There is a text box like in Google where you can write a query and then push the button to fetch results. This kind of system of federated text-based search has many benefits. It is easy to implement. There are many search engines available for implementing such systems. The usage is simple like in Google. Information retrieval can be distributed to local national web services, and data maintenance can be distributed there too. There are, however, also challenges in using traditional text-based search. Firstly, there are problems of formatting search queries. For example, if you want to formulate a query related to your life situation, this can be difficult. There are semantic challenges in the search engines as well. A search term may appear in irrelevant document, synonyms lower recall, homonyms lower precision. There are challenges with dealing inflectional words in Finnish and Estonian, for example. The systems may not understand the meaning of narrower, broader search terms or part-whole relations, which also complicates things. Understanding the contents of a document needs common sense and data, and search engines usually don't understand what they are doing. ChatGPT is a good example of a system that really tries to understand what the user intends and what the documents might mean. There are also problems of presenting the results. So visualizing, analyzing, contextualizing, or explaining the results is difficult without data if the search engine only returns a set of documents as result. Data is needed in addition to the documents. The key challenge is that search engines do not understand the contents of the documents. The fundamental problem we are addressing for publishing legal documents is that the content is available as texts for humans to read, but is not available as data for computers to use and analyze. Our vision is that legislation and court decisions should be published as linked open data on the semantic web so that intelligent web services can be created in a cost-efficient way. We chose to use linked open data as the technical basis for our work. There are several reasons for this. By using linked data, everybody's data can be collaboratively enriched by each other's data instead of publishing data in separate data silos. Everybody wins by collaboration. By using linked data, it's possible
to create findable, accessible, interoperable and reusable data using the FAIR principles. This means that the value of the data increases. Finally, creating more intelligent applications for the public, curators and researchers is possible. When the machine understands the data, it's possible and more cost efficient to create intelligent applications.
Leonardo da Vinci has said, learn how to see, realize that everything connects to everything else. Perhaps he can be regarded as the inventor of linked data as well, among other inventions he made. Also, EU administration has invented linked data. For example, EU Cellar already uses linked data. They provide knowledge graphs and Sparkle endpoints for querying the data. In our earlier project with the Ministry of Justice in Finland, we have created a system called Lawsampo, Finnish legislation and case law on the semantic web. This system and the software were used as a role model and a practical framework for implementing the proof of concept system Finestlawsampo.
This figure illustrates how the Lawsampo model and pilot system attacks the question, how can judicial data be used in applications? On the left-hand side, we have the data providers, in this case, different courts in Finland. They produce court decisions and they pseudonymize the data for the Finlex database legacy system maintained by the Ministry of Justice. From this database, we transformed the data into what is called semantic Finlex, which is a linked open data representation of central parts of Finlex database. From this data source, as well as from other data sources related, like EU Cellar, we create an enriched legal linked open data publication that is published at the Linked Data Finland platform. At this phase, we use tools like automatic annotation in order to enrich the data for intelligent services. This data service is then used as a basis for applications such as the Lawsampo portal and other applications, and here the Sparkle API is used in practice.
This image illustrates how the ideas of Lawsampo system are applied to the global transnational case. The idea is that national database services and data are transformed into a global knowledge graph. During the transformation, harmonizing data models are used such as EGLI, and harmonizing ontologies such as Eurovoc and live events of national systems such as those in Finnish and Estonian legislation systems. This knowledge graph is then queried by using Sparkle. On top of the Sparkle endpoint, we have created a faceted search engine, which is very similar to that of Lawsampo. And the idea there is that it gives the end user very rich semantic search and browsing facilities. And in addition to that, the results that you get from this kind of system are more than just sets of documents as results. In addition to those, we can visualize the results, do data analysis, contextualize the results with links to other data, and use metadata for different kind of purposes. The global strategy has many benefits. Harmonized data provides much more accurate results. The data can be enriched in different ways. There are new ways for implementing semantic search and browsing on the data. For example, search based on citizens' life situations or on legal topics. The data on a global level can also be enriched, analyzed, and visualized, which facilitates legal informatics research. The precompiled translations in this approach can also be more easily controlled and managed. Automatically created translations may be incorrect and contain hallucinations, which is a problem. However, the implementation of global systems is much more complex, depending on the number of local services to be aggregated and depending on the quality of the local datasets. In general,
New resources are needed for the centralized service too.
In our case study, we were able to enrich the harvested and harmonized data in many ways. We could provide internal and external links, for example, to the EU seller data. We created translations for every language pair in the system. For manual translations, we got already some documents ready to use, but then for the others, we used machine-made translations based on Opus machine translation system. Keywords were extracted from the texts based on the multilingual Eurovoc vocabulary of EU, and classification of status based on life situations were created based on Finnish and Estonian life situation systems for the public sector.
As for language versions of legislation, only Estonian law was available as official English translations. For the other language pairs, neural machine translation models were used. We used the Opus MT model and tool from University of Helsinki. Specific language pair models were used there. The previous sentence was always used as a context for translation. The metadata of Finnish and Estonian legislation was enhanced by keyword extraction. For this purpose, we used by Eurovoc for extracting references to Eurovoc vocabulary. After that, the keywords were extended by using iso-ontology and reinforcement. Based on the keyword vectors, then word embeddings were created and they were used for classifying the documents along the life situations, for example. This slide illustrates the life situations standardized by the Finnish public sector. There are 9 different categories, and the idea is that this kind of categories can be used to provide the end user data from different perspectives of life situations that he or she encounters. To test and demonstrate these ideas, we created an online demonstrator with 2 application perspectives. One for finding statutes in the Estonian and Finnish consolidated law, and one for finding EU directives related to the Finnish and Estonian legislation. This screenshot shows the application perspective for searching Finnish and Estonian consolidated law. The search is performed by using 8 different facets available on the left side, and the results can be seen as a table by default on the right side. It is also possible to visualize the result in different ways by using different tabs on the upper side of the screen. The language can be selected also either Finnish, Estonian or English, and depending on the choice, everything happens in the selected language. This screenshot illustrates the idea of visualizing legislation. In this image, the user has selected from the facets a set of consolidated laws or statutes, and on the right side, they are visualized on a timeline, showing the number of Finnish and Estonian statutes by year. The Finestlawsampo idea of creating a global knowledge graph versus using federated textures like in NLEX has many benefits and challenges as well. In the Finestlawsampo case, more versatile faceted search and browsing paradigms can be used for searching. This includes actually traditional text search as one facet. It's possible to get accurate semantic search-based results and also use hierarchically organized concepts. The link data approach is language agnostic, based on concepts, not on words in different languages. This is a very nice feature for implementing cross-border applications. In Finestlawsampo, it's possible to enrich contents with other legal databases. This can be done by linkage or by reasoning, because the semantics of linked data are based on logic. It is also possible to use visualizations and data analysis in addition to simple searches. However, there are also some challenges. Of course, this kind of system is more complex to implement. It requires more collaboration on standards and agreements between the data providers.
and it requires more work from the centralized resources for maintenance. It should be noted, however, that it's also possible to create hybrid models. It's possible to use distributed linked data services with linked data, and then use federated search on those. So in that way, some of the benefits and challenges can be mitigated. All in conclusion, I would say that linked data is the way to go for publishing and using legislation on the web.